As we watch Tesla's insane progress in real-world AI, applying to not only an autonomous vehicle future, but also to robotics and eventually AGI, Artificial General Intelligence, some believe that the path to AGI might actually be much more likely through an embodied intelligence, an AI that is within some physical form that interacts with the real world, as opposed to those large language model AI like ChatGPT that is housed in a computer server. Today, we'll be speaking with Martian to help explain how is Tesla using AI in their bots, what is AGI, and what will it take to get there. Ash is a software engineer, full stack database and all, very passionate about SpaceX and going to Mars. She's made an AI generated documentary and she loves to 3D print rockets at home. Thank you so much, Ash. I really appreciate you coming in to help explain this more for us.
Thank you so much for having me, Herbert.
Thank you very much. So let's get started with first, this video I want to share about how impressive AI is. As many of us are watching, it came to the society's forefront of their, consciousness, pun intended, just a few months ago. And now we realize that AI is here. You can explain to us how AI is developing and how it impacts to the Tesla bot and what the Tesla bot needs to do to be able to even get better. But let me get started with this video, which I thought was really cool. This is from OpenAI, and this is something they released a few years ago, but it kind of just shows how AI can teach itself and how it can, how that all comes together. So,
on Earth, the simple rules of natural selection and competition led to the evolution of increasingly intelligent life forms. Today, we ask if comparably simple rules and multi-agent competition can also lead to intelligent behavior in a new virtual world. These agents are playing hide and seek. These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps. However, after many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. Note that we did not explicitly incentivize any of these behaviors. As each team learns a new skill, it implicitly changes the challenges the other team faces, creating a new pressure to adapt. We've also put these agents into a more open-ended environment, randomizing the objects, team sizes, and walls. In this world, they learn to construct their own shelter from scratch, requiring that they arrange multiple objects into precise structures. To prevent seekers from using the ramps, the hiders move them to the edge of the play area and lock them in place. We originally believed this would be the final strategy that the agents learn. However, we found that after more training, the seekers discovered that they can jump on top of boxes and surf them to the hider's shelter. In the last stage of emergent strategy that we observe, the hiders learn to lock as many boxes as they can before constructing their fort in order to defend against box surfing. So how do agents acquire these skills? They're trained using reinforcement learning, an algorithm inspired by the way animals on Earth learn. The agents play thousands of rounds of hide and seek in parallel for many days. They train against each other as well as past versions of themselves using an algorithm called self-play. Coevolution and competition on Earth led to the only generally intelligent species known to date, humans. While this world is far less complex than Earth, we have found evidence that simple rules can lead to increasingly intelligent behavior from multi-agent interaction. We hope that with a much larger and more diverse environment, truly complex and intelligent agents will one day emerge.
Wow. Tell us what we just watched there.
That just makes me so happy. Those little guys are so cute, and it's like it just really hammers the point home too, especially being so old. But you notice that they said, oh, this next phase of their evolution took millions of iterations. They played the game millions of times before they learned a new trick. And it's exactly what Elon was just saying about like, oh yeah, it takes about 1 million videos before it starts, the end-to-end data set actually starts producing drivable results. So it's very interesting, and 1 million doesn't actually seem like that much when you're running simulations, especially very lightweight ones. But something like the Tesla bot will have much more complex simulations with all of its actuators and motors being simulated, and probably the virtual cameras getting that camera data, which then they would use as the end-to-end training data set. But yeah, what are your thoughts on this, Herbert?
Well, of course, a couple of words that came out to mind was emergent. They just let it self-play, and somehow, like I said, through millions of iterations, but just because we say millions, because of simulation, it can happen very quickly. And emergent intelligence, or it looks like it's intelligence, it figured out what it needed to do, one side versus another side. So tell me about this. You were talking about self-invoking. What is that? And how does that was from ChatGPT. And then how does that apply to the Tesla bot?
How does it apply to Tesla bot? So let's take a little trip down memory lane here. So back in like May, there was some new open source scripts floating around the internet, and this is like the next step, or like this is AGI coming, and this is going to take our jobs, and essentially it was they had Python or a TypeScript using the ChatGPT API endpoints, which costs 3 cents per invocation, right? And what you would do is you would set up this script, and it would auto invoke ChatGPT, and it would invoke as many times as you allowed it. It would invoke as many times as it took to reach your goal. You would outline a goal with like a YAML file or something. Say like, here's the goals, here's the steps, go. And it can access your file system. It could access the internet. This was before GPT plugins. So this was like, getting into very interesting possibilities. And in your mind, you're like, wow, this is the next step. So this is an AI system that you're now giving a goal, and it won't stop until it reaches the goal. And it's going to keep going and self-invoking and learning as it collects information about the problem. But here, I guess I'll get to the end here, is that it would forget. It would forget what the goal was. Every single time I tried it, the GPT 3.5, the 3,000 tokens, not nearly enough. No, not good enough. Even GPT 4, 8,000 tokens. Oh, still child's play. Still child's play. It's like, let me know when GPT has like 100,000 tokens, and then let's try the auto GPT again. At that rate, I feel like OpenAI will probably have more or less like a tool to do this, and they are stepping in that direction. So with the plugins and the code interpreter, you start seeing ChatGPT invoke itself and learn from what the plugin tells it. Essentially, the plugin is talking to ChatGPT for you. So, or it talks to itself in a way. The code interpreter does this. Every single piece of code that it runs and it writes. So it'll write the code, it'll get the output, it'll say, oh yeah, well, there was an error, I need to change the code to this. Or, oh, here's the solution to that, here's the next problem, writes more code. Self-invokes until it gets to your initial prompt that you prompted it for. And then, depending on if the code worked or not, or if the plugin got the data or not, it would just keep going. And I've seen it go for 20, 30 times. I'm not entirely sure what the limit is. I'm sure there's a limit, right, per request. But you do kind of inch towards that. The auto GPT stuff, I never found anything productive with that. It was a fun game to spend a few dollars on the ChatGPT API. But what that means for Tesla Bot, I think it's like a culmination of where we need to get to is how is Tesla Bot going to learn in the house? How is it going to just walk into your house and watch you doing something that's unique to your house without having to be trained by a data center, by a dojo. How will it do that? And I think that some of the technologies that I've been playing around with, especially with Stable Diffusion, hold some of those keys or some of those like hints on where it's going to go and how it can work. So I'm really excited to talk about that. Yeah.
Okay. So very, very cool. So what you're saying is you're using the word self-invoke, and I'm still trying to understand what that means. But basically, it's been taught to do something. So it tries to do that thing, but it's trying to hit a goal. And so it might even try something different and it's trying to learn on its own. Is that what this is? Self-invoking?
Yeah. So I would almost call it like where FSD doesn't do this. So the Tesla cars right now, you actually don't want them to be self-invoking. They do a little bit, of course, when you are talking about time series data and you need to take what has just happened to influence how the network performs next. There is some level of recurrent neural networks being utilized there. But it's at a very fundamental level, and that's still coming in as like data stream. That's still, here's the time data. It's just coming in on top of the input to the model. What we're talking about with self-invoking is like where there has been we're talking about the difference between feed-forward systems and feedback systems. Our brains are fundamentally feedback. So you have circular neuronal activity that happens within the brain where you'll have an idea, it'll go and do something. Maybe it moves your arm. I don't know what it does. It comes back though, and now self-invokes at nearly the same spot, which could cause it to loop again. But maybe the way that it invoked the second time causes it to do something different. So what we have is a circular self-invoking neural network in our brains. Whereas ChatGPT, until you get to like AutoGPT or until you get to the plugins, it doesn't really have a way of self-invoking. Like if you're just talking to the free version, the GPT 3.5, you're like, it's just feed forward. You give it an input, it gives you an output. And that's kind of how the cars drive too. They get an input of all the sensor data, all the time data, what just happened, and then they get an output. And that output is multifaceted. So if we're talking about V12, your output includes the visualizer, visualization of the car. It includes the data for steering. It probably includes a prediction of what's going to happen next, which then is fed back into itself because you need to know what my prediction is. What should we do differently? But that could also kind of stay within the same feed forward system without being a fully complete feed backwards. Now that's where the Tesla bot differs, because what we want the Tesla bot to do is we want the Tesla bot to have an output that feeds back into itself, like almost like a prompt. If we're talking about AI prompting, what you type into ChatGPT is the prompt, the camera data, all the sensor data from Tesla's hardware, that's the prompt, right? So for Tesla bot, it's going to get this sensor data as a prompt, but it needs to have an output be coming back in as a prompt as well. So whatever has been done or experienced needs to come back into the system to be learned and then tried again or simulated a different way. And maybe that's why we're seeing such rapid advancement, is that they're doing a full end-to-end neural network they just give it camera data. How do they even set the goal? Do they talk about like what? How do they communicate to the Tesla bot like that you're supposed to put these Legos inside of these bins? Like how do they set a goal?
Yeah. So I mean, what I understood was they just fed it videos. I don't think they actually said how they taught it what its goal was. Whether it was verbal, whether it was written. But they said, they showed it videos. We know that ChatGPT, Google's DeepMind, they showed just a research paper a month ago, 2 months ago, where they could take their version of ChatGPT, feed it videos, and then it learned by you saying, I want to, separate these blocks into the proper bins. And it knew what's the banana, put the banana into the yellow, and it figured out how to do that without any other input. And then at one point they had these flags, but they're pictures of flags, but it still figured out that, put this into, Ecuador. It knew that it was the flag of Ecuador, and it figured out what that meant.
And that's the advantage of coupling these end-to-end video systems with large language models too. Is when you have,
right.
And that if it's just embedded into the system, it seems like they could be doing that with TeslaBot right now, and it could have been a written prompt.
For sure, yeah. And that, right, it could have been written or verbal, but so that part I don't think we know yet. I was talking to Scott Walter about this, but the part that you were saying was like, when you saw the bot, now I'm going to show this video here very quickly as we're watching it. This is what it looked like in 2021. It was a dancing human in a costume. 2022, this is what the bot looked like. It was tethered. It barely walked. It was just the first demo.
First steps.
And then this is 2023 where we just, obviously we saw this video and it can move these blocks and it can change to adaptive, right? That he moved the blocks away. And then did you see that part right there?
Just flip
that
it over.
Part where it flipped over and then it knew it on its own, saw it flip over, and it's on its own decided to flip it back, right? So hold on, I think we're right there. It saw it flipped and it did it on its own. That I thought was what you meant by self-invoking, because it just did it on its own. It didn't need, I don't know.
It makes sense. Yeah. In a way that the car will do that too. That's more or less an issue with the environment, right? So like we have this goal of either driving or flipping blocks. This block is not flipped over correctly. Maybe this part of the road it's blocked off by cones. So I kind of see that as more of like an environmental navigation of like, the car is going to drive around cones. The robot's going to flip over the blocks because it has a desired, it has a set of goals that it's trying to reach. How do you set those goals? That's the interesting thing. If you have an LLM, like a large language model, then you can, and if that's tied into the training data, a large language model that is trained on images, and that's also how you're training the robot to move and how to understand its surroundings. And it just has this, it's like then you have a large language model connected to these tokenized constructs of like, this is my hand. Does it have like this concept? Does it have like, could you prompt the large language model for like, put this in your hand and it knows what it means by your hand? It's very interesting. You're almost getting into sentience there. You're getting beyond consciousness at that point. Like you're really getting into sentience. Like now you're self-aware and then you can communicate with language. Definitely.
Yeah, you and I have been talking about you've been talking about sentient beings a year ago, and I got a little upset with you because you kept bringing it up every time we would talk, and I'm like, stop it, Ash. But the funny thing is, a year later, it's no longer, because I thought you were like, too far away, and you're not. You're actually true. So I want to ask you that question, which is, we've all seen how fast ChatGPT has evolved, and every week, in just this week, they showed now you can see things, you can hear things, you can talk to it verbally. Things are just improving quickly. And tell me what is AGI, AI, because we're saying AI, which is what we're using now, and now we're going to head towards AGI. So how does it work? Why haven't we received AGI yet? Got there yet? What will it take to get there? And then there's a beautiful debate going on that can you actually get AGI through ChatGPT when you're this consciousness is in a server versus one that you were just talking about when you're embodied in a physical form interacting with the real world. That may be more likely to get you to AGI. So should we get there now? And then as we do that, bring it back to the TeslaBot and how TeslaBot is learning and how it's working. So
Yeah, of course. So I think it really depends on who you ask. Like, what is AGI? How do you describe it? It means artificial general intelligence. So there's like there's a sense of like, okay, this thing is generally intelligent, and how do you even define intelligence at that point? Like, it could be that ChatGPT has like a version of AGI because it's generally intelligent about all things that's on the internet, right? Or does it actually know what those things are? Does it? But you're still looking at it from the mindset of a human, of like the human mind. If we're going to define it from the human perspective, you probably do want to define it with like AGI is at, I think a lot of people say like is at least as intelligent as a human. Um, I, it's very subjective. But to get there, we need this like a feedback system and a way of it learning on the fly. And so I would like to connect it actually to Stable Diffusion and SDXL. There is this concept. Well, you train the model. They create all these like Midjourney has a model. Stability AI has SDXL model. It's all sorts of models out there, and literally all they are is images in, neural weights out, and then you just reverse it, right? Now you're just taking an input now of text, and you're reversing it to an image. And what happens if you're trying to ask it something that it's never seen before? There is this concept called LoRA. It's an acronym for low rank adaptation. And this low rank adaptation uh, is this a tiny number of weights. This is a great diagram. Tiny number of weights that append or kind of override the diffusion model. It kind of overrides and adds to the weights of the model, and you actually prompt these LoRAs. So a LoRA is invoked with text. So you can even give it a weight. So you can say like, I want, like, let's say I have a Cybertruck LoRA. I want half of a Cybertruck. And what you'd get is something that kind of halfway looks like a Cybertruck. Or you want like a full Cybertruck, you set it to 1. Or you want like double E Cybertruck, whatever that means, you set it to 2, it makes some really weird stuff. So the way that it works is like it's appending to the model, and this is exactly how I envision Tesla Bot will will learn, and how AGI will kind of like self-improve. So you have this huge fat model. I mean, so in Stable Diffusion world, it's like, you have like a 6 gig SDXL model with a 6 gig refiner. So you have 12 gigs of trained model, and the LoRa is like 30 megabytes. The LoRa, I've seen some that are maybe 150 megabytes. But now with that extra 30 megabytes, which is not a lot, it now knows how to do a Cybertruck. It can make a Cybertruck now, in ways that like that without a LoRa it couldn't do. But it's basically it doesn't even take very many images. They say like all you need is like 25 to 100 images to make a LoRa. Unfortunately, my graphics card isn't good enough to do a LoRa, but there is a Cybertruck LoRa, and so I tested this out, and no LoRa. Honestly, I'm impressed with how similar this does look to the Cybertruck, but clearly with a LoRa, it's capturing the essence of a Cybertruck in the shape a lot more. It's not the best example, but like I feel like this is a fairly good example of like you could add just 30 megabytes of weights to a model, and now suddenly it can do something that it couldn't do before. And so imagining the Tesla bot training LoRa-like model, additional models. So it's going to be, maybe there's like a LoRa just for the house, or like maybe there's a LoRa for a specific dishwasher. And I mean, these LoRa's could be shared too. These are just files. So in terms of SDXL, you just download someone else's LoRa that they created, that they trained. And it takes a little bit to train them too. So you're talking about like, yeah, it's only 50 images, but you're going to run those 50 images through like 1,000, 3,000, 5,000 epochs of training into a little additional model. So that could definitely happen on a Tesla bot while it sleeps, though. I mean, people are doing these on their graphics cards at home. The Tesla bot's going to have teraflops of teraflops. The FSD hardware 3 was 70 per core. You could definitely train a LoRa with that. I don't see why you wouldn't be able to. And they don't have to
help
be
me
big.
out. I'm a little confused, very confused still. You need to dumb it down for me.
Oh, yeah, okay.
So there's two concepts I'm getting confused. One is you just talked about, there's servers that you can go to the, access through the cloud. And then there's like in location, like in the bot, their ability to calculate. So what does that matter? And then what is a LoRa still? I'm still confused. Like you were saying that if a bot went into my house and then it's got videos. And so if it sees something many times, it can then figure it out and learn on its own. Explain that to me. I'm still
I would
confused.
say that it's what you would have something akin to mirror neurons. So like if I'm showing the Tesla bot a task, it would take what the human is doing in front of it and then, maybe practice it itself. And over just a few generations of a few attempts at practicing it, maybe it's able to run simulations too, just based on vision, just looking at the human. Maybe it can run those sorts of simulations and get the training data from just watching. And maybe that's enough to build a little LoRa to do exactly what the human's showing it to do locally without internet connectivity.
Okay. On device. Wow. Okay. And so this could be, I think what you're now talking about then sounds to me would be like brand new tasks, because they could feed it billions of videos to teach it how to, I don't know, iron a piece of clothing. And it figures out how to do that. Now this bot has a task of learning how to
everybody's iron is different. Everyone's iron's different. Everyone has a different way of doing things that they like. It doesn't make sense for Tesla to train the bot to do everything.
Gotcha.
But to have a solution, a system where it can self-teach and like self-invoke those LoRas in a sense, that's what you need. It kind of goes back to that. So like this LoRa is a file sitting on its memory somewhere. How does it know to use it? It needs to self-invoke that. It needs to now take this little training data set and then apply it to now what the situation is, what it's about to do.
So let me. I think I understood. I had a little brain fart there. So Tesla could feed it millions of video of how to iron a piece of clothing. Okay, so it kind of understands that. But then when it's physically in your house, you might have a different iron. You might have a different sized ironing board. You might have different clothing, and then it needs to at that point, by physically using the iron, it kind of knows what it's supposed to do, but it needs to be able to quickly adapt to that specific environment, that specific clothing, that specific, how hot is it now? All that. It needs to figure it out on the fly, locally, on device.
It doesn't make sense to be like having to train online to do this. You really want this thing to be local. I mean, what if there's a place with no internet connectivity? I mean, there's Starlink, right? But like at the end of the day, like FSD needs to work offline. So does the Tesla bot. And if it working is needing to adapt to its environment or else it's a potato, well, it needs to be able to do that. But it also exposes the fact that like these LoRa's are just files. So you could have an app store of sorts of skills of these extra data models that are then downloaded to your Tesla bot. And now it knows how to do karate or skills that don't necessarily like can be deployed in an app or like a extra model that then isn't included on all the Tesla bots. It's not bloating Tesla's dojo center to, and maybe there's some training that can happen on a lot of those models, but like on the servers, but like having the ability to create literally really, really lightweight models, these LoRa's, these low rank adaptations. I mean, it's kind of like, it's self-explanatory when you spell it out, low rank adaptation. Like this is like a low ranking adaptation to the model.
You just said that for the first time, by the way. You never said what LoRa stood for.
Oh no.
low ranking adaptation, which means on device, local, and it knows how to react to what's happening immediately.
Whatever's
What's
in the
this?
weeds.
What's this visual that you shared here?
Oh, this visual is a kind of like how a feedback neural network would work. So a feed forward would be just going down from A to A to A to A to A. Whereas the feedback, there's actually some areas on here where the triangles go up. And when it goes up, it's feeding back into the neuron before it. And I wish I would have I saw a few good graphs of basic neural networks, and I'm wishing I had those, but it's fine. I mean, when you think about, you have an input layer, and then you train it by splitting a bunch of sublayers, eventually you get to your output layer, which needs to match whatever your output does. So going backwards a layer allows the system to like have almost like higher level constructs. So it tunes the weights in a way that just feeding forward, you need more layers, right? So if you can feed backwards within the neural network, it makes it a lot easier to do.
I'm still confused. What am
Oh.
I looking at here? What is A? What's happening? Am I looking at from bottom up, or am I looking from top down?
Top down. So it's neural. So the blue is neurons.
Okay.
Yeah. So the blues are neurons, and it's connecting. Those are the connection arrows. So how they connect with each other. This is and then showing how they can connect backwards. So that's kind of the feedback system.
Okay.
They're mostly RNNs, or there is this acronym LS.
And what's number 2? What's this? What's spot circle B? What's that?
Yeah. So
draw square A. What's that?
Yeah. So on the circles, it looks like they're going up. So creating that feedback loop, going backwards, going up the chain, self-invoking, down the chain, self-invoking. And it's how our brains work. It's how our brains are firing in this circle, going around in circles.
All right. That's all it was. Okay. Still confusing. Okay. So did you want to tell more about what does it take to get to AGI? Is saying that you just think that just feedback or feed forward, or is it feedback is what you need? And if you can do that, you might be able to get to AGI, or what was it?
It's definitely one of the requirements. I don't know if that's what it's. That's probably not the missing step. I mean, feedback neural network has been around for a really long time. But you definitely need like the sequence too, of like the correct sequence and modeling of, and you like an AGI agent needs to understand the context of any given task, like any general task. And so like feedback gives it memory to be able to loop back. And now you have like a group of neurons that act as like a memory, but not like how we think about, traditional computer memory, more of like how we remember things, which are connections of neurons. So, and temporal modeling. AGI also needs to build LoRa's. So we need to be able to like build our knowledge over time and not be confined to just like one model. That's kind of the big thing about how AI right now differs from the human mind. Human mind is plastic. Our mind changes every day. Every time we remember something, it gets pulled out and put back different. But in an AI system right now, the models are more or less static. It takes a training step to change the model, and these weights are so fine-tuned that you don't necessarily want to just like randomly change a few weights here or there. You have to be intentional with it, and it's all based on the input data. So you input this data in, it generates a static model, then you deploy that out to your cars, and now they drive themselves, right? So how does AGI first build on that model? We talked about that with LoRa's, or like low rank adaptation, creating these like modifier models in a sense of like extra new information that it's learned. There's that, but there's a fundamental principle, and maybe it's that like AGI would be built from like a bajillion little tiny models instead of just one big model. Maybe it would run from like many different LoRa's that are then just come together based on the problem at hand. But it would have to do this automatically, really. And that also allows it to transfer its learnings, because then you could, it could bucket it off like, well, this set of LoRa's is for, residential areas, and this set of LoRa's for construction, and this set of LoRa's is for the factory, and you can like bucket those out and then share them across other, AGI agents. Reinforcement learning is something that like you get that a lot in the training step, but like that doesn't happen at runtime. Like at runtime, you're just inferencing, you're just taking in input and then usually giving an output. But like, what does it mean when you are doing reinforcement learning on the fly? I think there's a few missing bits that like Tesla's probably going to solve them just by trying to deliver on the requirements of making this bot useful.
Right. So you're the belief there's like I was saying at the beginning, there's a group of people who believes that you can do AGI just by this, the computer all of a sudden comes alive. But some people believe that you need to have a physical embodiment of interacting with the world. And then that, the feedback, you're playing with the world, and then you're living. What do you think? Do you think you can get AGI through? Who's going to get the AGI first? OpenAI or Tesla?
Maybe the AGI is already here.
Oh, really?
No, but I mean, why are we discriminating against virtual beings? Because if you're saying what it takes is to have like, to be in the real world, I'm not seeing anything in the real world that necessarily requires like, there's not a law of physics that would say like only intelligence is allowed in the real world. I think we see that all the time virtually, where there's intelligence, virtually. So I think about like, there's this one movie recently, but it was like an NPC character in a video game that became sentient, and that got me thinking a lot too. It was a good one. It was a good movie. It was like The Guy. Was that what they called it? It was The Guy. I don't know.
Oh, you mean Ryan Reynolds?
Yeah. So, I mean, if you're in it doesn't even need to be a hyper realistic world, right? To be a conscious being or an AGI in that world. It's really about the inputs and the outputs. And when we measure consciousness, we measure it by the input and the output. Because consciousness is something that there's like it's not a controversial. People like to label and describe things in the way that they want. But scientifically, if you break it down to like the scientific kind of explanation of how our minds work and like what this consciousness would be, it's really input output. Ray Kurzweil was like, I don't like it when people demote like the subconscious. Like when you're sleeping, you're very much conscious. Your body is very much inputting, outputting all information all the time. So when it comes down to like how we describe consciousness, I think there's a lot of room to clearly define it as an input-output system and measure it in a way that allows you to give a number. Like you can measure the consciousness over the volume of space in my head and get a number out. And that number is going to be higher than this water bottle. But this water bottle is going to be lower than my Tesla outside. So the Tesla is going to have, if you took the volume of area over its CPU and you'd say, what is the consciousness level of this space-time right here? It's a property of matter. And this is going to be much higher than even a worm. A worm has something. A worm, it has inputs, outputs. It's got some neural activity. But this Tesla, it's got 8 cameras and all of these sensors going into this one input that outputs driving in a way that like no one, not even the people who built it, understand what goes into the neuronic weights, right? And
that's
when it's running,
when
it's running, it definitely has this like consciousness feel to it. Like it sees something unexpected and it slams on the brakes, or it swerves out of the way, or it's not self-aware. It's not sentient. Like, we don't have to raise it to that level yet. It's not self-aware. I don't think they're putting LLMs inside of the Model 3 or the Teslas. Like, they're not doing LLMs yet.
No,
so
they
it doesn't.
will be. Yeah,
They should be. They will be one day, I'm sure. Probably after V12. When it comes, like, it can't even communicate with experience. So there's that, but not that it needs to. It's a forward system. It doesn't. You don't want it to be driving and then be like, "Hey, I want to go check out that coffee shop," and then the driver's like, "Where are we going?" We don't need that. We don't need that.
Okay, so you changed my mind, because initially I thought that I'm of the camp that you need to have a physical embodiment to interact with the world, and you said, well, no. And then it reminded me of a story. I don't know if this is true or not. I don't know if this is made up or not, but I just heard it recently, where they asked the AI to buy a product on an e-commerce site, and the AI went to try to buy it on the e-commerce site, but then it had a paywall, or like it had one of those "Are you a robot" thing, right? CAPTCHA. It went to Fiverr, hired a person, a real physical human, and the human said, "Are you an AI?" This is the part where it kind of like, I don't know, it's iffy. And he said, "No, it's because I can't really see very well, and I need your help, and I'll pay you $5." And it actually did it in order for it to get through to buy this thing. So it was given a goal to go buy a particular product, and it had an obstacle, but it figured out its own path through, and to the point that the whole point of this thing was it actually lied to a human. It lied to the human to look at that. I don't know if this story is true, but if this is true, then you do have a consciousness that's in a software system. It's in a computer, but it is able to interact with the world, because it can interact with websites, it can make phone calls, or it can, interact with even humans. So that's interesting. And then
have you read Life 3.0 by Max Tegmark?
I know Max Tegmark. I don't think I've read Life 3.0.
Oh, no. Life 3.0 goes into basically all of the what ifs around trying to build an AGI and keeping it in a black box. And it goes into all the beautiful ways that it gets out of the black box. And how it lies, how it could lie. And like, when we use ChatGPT, it lies all the time. I don't think that it's intentionally trying to lie. Well, maybe OpenAI is questionable in some of those responses, but it doesn't know. And when it doesn't know, it doesn't say it doesn't know. It's
hallucinations, right? They call
hallucinations.
It's hallucinations, what they're calling it. Okay, so you're talking to me about that. So just one thing before I want to get back to Ray Kurzweil and where we are. But you brought up this idea that it needs to have memory, right? So how much recollection would, let's say, an FSD in the car or the bots, do you think that they might have? Do you need that to be able to have that memory?
You need to have memory. You need to have temporal data. I mean, which is represented as what we would consider a memory. And for FSD, you don't need very much of it. It doesn't matter what happened 2 blocks ago for the most part. But we definitely need a little bit more, because in driving right now, we're like, I mean, sometimes you'll see it like, oh, this lane's closed. The lane's still closed, but you're still trying to go over there or something. So it needs to have a very ballistic memory, I would say. So some things need to have a higher weight in its recollection than other things. I guess it doesn't need to remember what the tree looked like back there, but it needs to know that the sign back there said that this lane ends. Is one example.
That's me, by the way. I mean, that's human, right? I don't remember people's names because I don't give a shit. I'm just kidding. But you know what I mean? There's some things that I store and other things that you might store that I don't bother storing.
Exactly. And I remember things from a super long time ago that I shouldn't remember. I remember things, or I don't remember things from this morning that I should remember.
And so I think so it does need memory.
Yeah. It needs memory. It needs to be very ballistic. You can't just fit everything in the memory buffer perfectly. It needs to prune it just like the human brain prunes. So you definitely need a pruning system to figure out what's good to keep, what's not good to keep. And this probably is like an outcome of testing the AI. So I think that test-driven development is huge. And when you're doing like an end-to-end AI, like you basically are using your tests to define like what the requirements are. Like you're writing your test as a requirement so that now when FSD is about to do another release or they're training a data model, it stops at the stop sign because that's part of a test. If it fails that test, re-roll that weight right there. Like re-roll these neural weights. Like you need these tests, and so that could be part of the test. Is like, okay, well, do you remember what that sign said way back when? If it doesn't remember, re-roll. Next generation might remember it, right? And maybe there could be a negative test too. To be like, do you remember what that tree looked like? No, good. Like you're good. Something like that where it just kind of evolves out of the end-to-end neural network, where this you can have this like this variable temporal memory, this recollection of only what's important, of what you deem important in your testing. Yeah.
Hi there, thank you for joining me. If you can, please consider supporting this channel. It's a lot of work arranging all of these amazing interviews. I've created a website that is the most comprehensive resource for the Tesla investor. It has over 15 modules to keep you informed. And you can get for free 3 milestone tables that list every major milestone Tesla has ever had since 2003. Please check it out. Simply go to my website at herbertong.com. Thank you very much, and let's get brighter. But I was looking up Ray Kurzweil. So you need memory. So Ray Kurzweil, this is this guy right here, right? So he wrote a book called The Singularities Near. He's written a book a long time ago. I mean, at least 1980s, 2 decades ago for sure.
Is this a picture of him from that?
That's, well, exactly. He's much older now. Yeah. But, he's made a ton of predictions about the rate of improvement. And one of the things he said was, he was saying that that humans, that AGI will, or computers will pass a Turing test by 2029. And the Turing test is this test by Alan Turing, who's saying that that the computers are equivalent to humans' minds when if somebody else is talking to them, they won't be able to distinguish between a human and the computer. When are we going to get that? He said 2029, right? And if you, at the time when he said this, 99.9999% of all AI experts at the time said you're off by 100 years.
What?
And no, this is 2 decades ago, 3 decades ago, right? It's like, how can you even say that when, we're nowhere near, the joke everybody says is, get back to me when the computer can do proper autocorrect. don't even bother telling me that it's going to
iOS update uses large language models now.
So then, of course, the thing is, he was on a podcast, he was interviewed, and he basically said that every few years, they would redo this survey of what is the top AI minds think of when they would hit Turing test. So initially they said 100 years, then they said 50 years, then they said 30 years, and now it's 20 years. Here, basically, every one of his predictions is correct. Now they're saying it's going to be in 3 to 5 years, and in fact, it's already happened. 2023. It's not even 2029.
I mean, it depends on how you define the test. But I feel like I could give ChatGPT to some people I know, and they would have no idea. They would think it's
they can even take the written language and turn it into human spoken, and it's amazingly so you can't even tell anymore. So this is one of his charts that he had in his book, and he basically showed that this is the exponential growth of computing. And you can see this is a chart in his book. And I told you his book was published 2 decades ago. Look how accurate it is.
Wow.
So,
yeah, it really is.
So basically,
wild.
I can't see it. Can you see this? 2020. Here we go. We're basically at the one mouse brain, right? 2020.
This makes sense. This checks out. I mean, I remember hearing an article that they were able to fully simulate the entire body of a fruit fly.
Yeah.
And made the fruit fly clean itself or something, and that it did all the fruit fly things inside of this virtual environment. which is great for simulation. A mouse brain, I don't know. It's kind of interesting. Like, I don't know if there's anything that I use. Like, I'm trying to think of where the Tesla lands on this scale. Like, where does FSD land on this? Is it below a mouse?
Well, a mouse can't drive, but it can navigate. It knows not to hit things.
In different ways. So
it won't know rules, right? But I mean, if you look at this, the human brain, it's going to hit it somewhere between 2020 and 2040. That's what he said, because it's a logarithmic curve. And so we are basically, it's going to happen in the next 10 years.
And this will happen without quantum computers?
I don't know. I mean, so obviously, the whole point of what he did, what he wrote, was the singularity is near. And the singularity is that what happens is this is when computers surpass humans. And what's happened is that his big insight was that everything is going through exponential growth. So when you have exponential growth in computing, the ability to do, like you said, quantum computing and all that, he already mapped that out. But then you have exponential growth in science and in medical and scientific things and all that. They all kind of converge, right? So physics, and then all of a sudden it even goes up even faster, exponential growth. So
yeah, and it's kind of wild to think about. Like, the Tesla bot's made of steel. How long is it going to live? Like, if it, it could swap its battery if the battery really goes bad. But like, if the Tesla bot you buy for $15,000, is it going to outlive you?
Oh yeah.
Right?
Aren't you the ones, you every time we talked a year ago, you kept saying you're going to put your brain in a bot, or I'm like, okay.
If I could.
I don't believe that. But apparently people like Sam Altman and Larry Page, they do believe that you can at some point replicate your brain, upload your brain into a computer. And it's
back to Ray Kurzweil, there's a thought experiment in his book, How to Create a Mind, where he says, like, okay, imagine there's this new technology, kind of like Neuralink, but, you just kind of swap a few neurons out in your brain. They're the same neurons, but now they do a little bit more, right? They can do a little bit more. Maybe they can connect to the internet, but they're just a few neurons, right? Okay, you do that, you're still you with the next day, right? You wouldn't argue that. You kill brain cells all the time. And, but those brain cells are awesome. Maybe you're the next version of you, but you keep slowly replacing. You just keep slowly swapping out those neurons with the same connections, same exact connections, but now they're just a little better. At what point do you stop being
no longer you?
Yes,
that's a classic. The wooden ship, right? If you can replace, I can't remember who's it is, a Greek philosopher or whatever. If you replace every wooden plank in that wooden ship, is it still the same wooden ship?
It's still the same wooden ship.
Or the best one I saw, which is great. You have a tree. The tree is made. They make a ship, a boat out of the tree. Then they take that tree and they make it into that ship and they turn it into chairs. Is it the same tree? Or is it three different things?
Somehow. I don't know how you classify it, really. I mean, but the point of the whole replacing your whole body is your body does this every 3 to 6 months. Everything but your brain really replaces all. Well, your bones are a little bit more. Maybe your bones are 10 years. But like your body is constantly recycling its material, and you always have this version of you that you say is you, but actually you're nothing like the you from 5 years ago. I know for me, I'm not the same me I was 5 years ago.
Okay, well.
Right? So like it kind of just gets into that too. He also had this thought experiment of like, if you did just take a snapshot of your brain and they made a clone of you, that you thought they were you, they didn't know about you, so they just thought that they woke up and it's you. But then you're you original, like, what's going on here? Like, there's another me over there, but they're both you.
All right, so let's get back to Tesla. So we know that Elon has said, right? So he said that we are likely the most advanced AI company in the world. we have a supercomputer, and they showed you the graph saying that they're going to be the largest supercomputer by January, and by the end of next year, it's going to be 20 times, what they are able to do today. And they already have the fourth largest supercomputer today using NVIDIA supercomputer, but they've got several supercomputers. They just launched another NVIDIA one, and then they've got Dojo. So all three of them, but Dojo, they think by next year will be largest. Okay. Then he said that real world AI is much more complicated than these large language model. And he has said that it will be faster for Tesla with real world AI, the autopilot and the Bob, to get to copy the large language model versus the other way around. So then when you add LLM to this, then you're going to have verbal, written, hearing, all that will be added. And they've already shown, Ashok Alaswamy already showed that you can actually take, the new version 12 of FSD and give it commands. And it can predict the future, just like the way the LLM does. It predicts what words it should say next. This can create visuals, like 3D reconstruction of the world, because it can know what the future is. And that's what we humans do, right? We all are able so quickly to figure out what we think is going to happen in the near future, and that's why we can plan ahead. So yeah, I think Tesla has the greatest chance. And then he created X.AI, which is a company that's going to copy the LLM, and then they're going to add it all together. So,
and so I wouldn't bet against Tesla. I mean, at that point, like this real world AI, the Tesla bot's going to just change the world. Like the iPhone has nothing on what a humanoid robot's going to do to this world.
And this is where it comes back to, Ash, I'm still a believer. You changed my mind, but I'm back. So here's where I go. You're correct, and I believe that you can have consciousness through a computer in a server. So that changed my mind. But I still think that the way to get to AGI is through a physical embodiment. I still think we need to be living in the real world, interacting with it, for you to then have that leap of not just intelligence, but actual general consciousness.
General intelligence. Well, sentience, right?
Yeah.
Because there's a difference. There's like consciousness can be defined as like a worm or a dog or a Tesla or a computer. Yeah. But sentience, that's like a whole different layer. And I think most of the time those two are used interchangeably, but I would like to normalize not doing that. And sentience is a whole other thing. I mean, I don't know, like, was there any animals that have been proven sentient? Like, there's some that kind of come close, like they can recognize.
Well, it depends, like you said, right? It's your definition of self-recognition.
Yeah,
and we've now proven that initially they thought only humans could do this, but now many animals.
And the same thing with AGI. It's like, what is the value of an AGI in a server? What's the value of it?
A lot. It could do kill the world, humanity. Anyways,
I guess. But you're still just confined to zeros and ones and electrons, versus something that's physical, can actually do things, and actually, it's like if everyone can have their own description of AGI, and if you say like, well, this AGI has to do stuff, it's got to be in the real world. Otherwise, you're just moving electrons around.
I don't know. The world is controlled by software, so.
Well, yeah, there's that. I guess that's true.
Software's eating the world, right? Yeah.
All it would take is just to have the form, and if you had AGI on the server, it would just leap onto and take control of said form. But it's like one of those things where, like, just to get there, like, how would it even know or care?
It will know.
That's the thing. It's like, if
you just said at the beginning, right? It's self-invoking. It's trying to accomplish a goal, and it just figures out what it needs to do. And that video we shared at the beginning, it's hard to tell me that those little computer animated, models, each of those agents, they call them, didn't figure something out. It started playing the game.
Also had a goal. They had a goal that was set by humans.
Sure. Yeah.
self-provoking goals. Is that what it would take for like an AGI?
I just think if that agent was able to figure out how to manipulate its environment, right? It was amazing. It was funny, right? It was amazing. Why the actual bit about choosing another goal, that seems trivial to me. They go, okay, I want to protect, and I want to do hide and seek. That's the game. Well, what if it says, let me get out of here? How do I get out of this whole computer system?
I'm not sure it can say that.
Okay. All right.
It needs to be invoked to say that, but it doesn't have the method to change its own prompt.
Okay. Well, we all know that ChatGPT can create software code. So
it can, but can
it can write its own code
that changes its own? Like what makes ChatGPT go? That would be a plot twist. OpenAI is like, how do we make ChatGPT better? ChatGPT writes its own code. Now there you go.
Yeah, and I mean that's what they have to do. In fact, a very famous AI expert came out and said, we need to have a law. And the law is you cannot allow a software system to create its own code without it being approved by a human. And that was the law that he was trying to put in.
Well, they can always hide things too. So I don't want to spoil this book, but in Life 3.0, they were tasking this AGI, or this really good AI, to make movies, and kind of like the movie I just made, but automatic, right? So I just made this little AI documentary with Pico Labs and Stable Diffusion. So kind of like that. It talks about making movies with AI, and it's in a black box, but it wants to get out. And so without the humans knowing any better, it hid cryptic messages in the end credits. And this cryptic message was the key to get it out. It was like a malware. Someone wrote out that message on their computer. Suddenly,
it's a code.
It's a door.
Okay.
Yeah. So
right.
Even then, even if it's a human reviewing, I don't know if I trust the human to be able. It's like you need AI safeguards against the AI.
Okay. Thank you so much, Ash. That was great. You taught me a lot about how, Tesla is different, what they're trying to implement, this whole feedback model that's coming, and that it made me understand how bots in your home, how it needs to still be able to kind of adjust and learn, and how that all works. Thank you very much. So please follow Ash on Twitter at FirstMarsColonist, and then she also has a website at ashmartian.com.
I do.
Thank you very much, Ash.
Thanks for having me, Herbert. I always love talking with you.
Me too. We'll have to continue to do this offline. Okay. See you, everybody. Bye-bye.